Hello, Dr. Greg here with another video about our nervous system and how it works. I think this is one of the most important things for us to understand on and to help us figure out how best to live so that our nervous system works the best it can and our brain works the best it can. So let's just review what we went through last time. We have a nerve cell, right? Okay? And that nerve cell needs three things to survive. It needs activation, which is doing something. It needs oxygen, makes sense, and it needs glucose. Now, the activation only can occur when oxygen and glucose are in the cell. And there's in the cell, and in every cell in our body, mostly every cell in our body, we have what's called mitochondria. Now, mitochondria are classified as organelles. Now, organelles are just little organs. Our heart is an organ, an organelle is a little, like a little bit, a little piece of our cells. It's found in the cell itself, and it's for the factory of the cell. It produces energy. It uses oxygen and glucose to make what we call ATP. ATP is the energy currency that our cells in our body use to do the things they do. So if a cell needs to get excited, and that's kind of what a nerve cell does, it gets excited, it sends an impulse through this chain right here, which is called an axon, and then you have the ends of the axon, which is here, that attach to another brain cell to get that excited. So a series of activations occur along a chain to help you to move your finger. So moving my finger, and I think to myself, I want to move my finger, the cell here gets activated by moving my finger. It uses energy, which is produced by glucose and oxygen, to make this cell do a action potential, it's called, an action potential. And it goes down this chain of axon, which I'll describe what these yellow things are in a few minutes. And then these are the ends of the axon, which then attach to another cell that excite that cell, activate it so it uses energy to go ahead and produce another chain, all the way from here, actually this side of my brain, through a nerve that goes all the way down to my arm and my finger, and I could do that. And I could do that pretty well. And that is using my brain power to do that. Now, we all know what fatigue is. We've all been fatigued. But there are some people that are fatigued pathologically. In other words, it's a horrible state to be in. They can't even move their hand. Why is that? Well, the nerve cell doesn't have enough of the right mix of energy, of product, in order to produce the energy, so you can do that. So what I'm trying to tell you is fatigue comes from your brain, which actually comes from the nerve cell itself on the very lowest level, and produced the organelle, which is even smaller than the nerve cell because it's in it. It can't produce the energy, so you can do this. Same thing, you can't think right, you can't even stand, you're tired, you want to sleep all the time. That's a lack of energy. That is what they call an energy crisis. Now, there are certain situations that occur when you can't use the glucose, the nerves can't use the glucose. And we're going to go through the very basic part of this, is that glucose enters your brain freely, right? And then the cells pick them up and pick up the glucose and use it and put it in the mitochondria along with the oxygen to produce this. Now, sometimes, a lot of times, that ability to take up the glucose by the nerve cell is broken. So it can't take up glucose. Or there's too much glucose for it to take up and it kind of fizzles out. And it's all related to insulin. You know, I talked about insulin with the sugar series. So what's important to understand is that the basic principle, the foundation of most of our problems with our brain stems from the nerve cell. When you have a stroke, you kill nerve cells. When you have a concussion, you put nerve cells at a disadvantage. They can't use the glucose and the oxygen properly, so they don't have the energy, so you're fatigued. That's what happens. When you don't get off the couch, when you don't move your arms or even think out of watching a TV program, you read or anything, you're going to lose the activation. The nerve cells can have all the energy you want, but if you don't activate them, they're also going to get weakened. Just like if I don't use my muscle here on this one side and just do this one, this is going to get weak and this is going to remain strong. If I don't use it, I lose it. And that's the key to keeping your brain healthy. And you keep it healthy by a variety of things, because the nerve cell is the linchpin. The nerve cell is the beginning of all things. And we want to ensure that the nerve cell gets what it needs so our brain works normally, so that you can do this. And you can imagine all the way down to your toes, you do that at your toes. It's a longer distance, but it happens just as rapidly as this can. Now, I wanted to tell you what these yellow things are, okay? And here's an interesting thing. So these yellow things are insulation. Now, they call this motion, when this gets excited, a transmission, just like a wire in your house, sends information down this axon to the end. What happens is when you excite it with this insulation, you have what's called saltatory transmission. You don't have to remember that word. And it jumps each of these yellow things. It jumps. You see where there's a space there? And it goes faster. Now, most large nerve cells, big ones, have this. So it can actually respond quickly. So if you move out of the way of a ball coming at your head or a punch or whatever, that is because you have this going on. Now, what happens when we slow down? When you, like with Parkinson's or Alzheimer's, you're a lot slower. You're shuffling, you're a little bent over, right? Part of the problem is you're not getting activation and proper energy in here. But the other part is that these yellow things are not helping out. They're sort of degenerating. And what are these yellow things made of? They're made of fat. Cholesterol has a lot to do with producing these yellow things. So if we don't have enough fat in our brain, the brain is going to slow down. Now, the brain is 60% fat. That's a lot, a portion of the brain that's responsible for making this work. Think of the fat on these nerve axons or wires as insulation. So if you have wires in your house that are not insulated, they will short circuit each other and there'll be problems. That kind of happens with your brain. So I've just added another thing to the mix. Not only does it need glucose, it needs oxygen, it needs activation, it also needs fat in order to be able to produce these yellow things so that you can do this. This is my brain. And this is my nerves that are in my brain, and I'm using up energy to do this. Now, not a lot of energy, right? But I'm using it, and I need it. Some people can't even do this because they're so tired or so fatigued. So let's review. We have the nerve cell, the basic unit of our entire nervous system. It all comes down to the nerve cell and how the nerve cell is treated. It needs activation, which is any kind of movement, any kind of thought, right? It needs glucose, which is food. It needs the right amount. And it needs oxygen, breathing, right? Breathing. And it also needs fat. We'll go into the specifics of that, but I just want you to understand what a nerve cell needs in order for it to function normally, so you can do this. So you can talk, so you can eat, so you can look, so you can walk. You actually walk with your brain. I know that sounds kind of weird. You don't walk with your legs, you walk with your brain. And the fatigue in your legs can actually be coming from your brain. The interesting thing is, pain will cause your brain to get tired faster. So any kind of chronic pain impacts this. There's a lot to go through, but I just want you to understand the basic building block of our nervous system is the nerve cell. Now, there are nerve cells that don't have this covering, and they don't have a covering for a reason, all right? Our whole system is elegant in how it's working and how they work together. So that's all I have for you today. This is Dr. Greg, changing the way we look at health, and thank you for watching.